Okay, I hope you can all see that and hear that. You just move this window out the way so I can see.
That's right.
Okay, so this work is entirely speculative. I'm going to talk about the future and not the past. So we can find out if we believe anything that I'm saying. This is largely reflecting a proposal that we have put into the Copernicus Climate Data Store, and we are more or less confirmed that we should get the contract, so this work should go ahead. But we're talking about WPS processes and taking a slightly different perspective, in that we're not trying to do anything clever, but we think that it's really important to have a lot of testing involved to make sure that our WPS is robust and reliable. So I will make an argument for that, and then you can question whether you support it. So we've been working with DKRZ quite a lot on various Copernicus projects and with IPSL. And so between us, we have quite a lot of experience of WPS as a way of providing remote processing. So one of the issues I would say is that it's quite easy to create a web processing service and that provides access to some data and that will work with some data. But conversely, it's very hard to provide something that will work with all data. And so even within something like CMIP5, you can do some testing with a few data sets and it all looks fine, but users might find that when they select different data that they get errors. And the case is normally because the data is very heterogeneous. So I would also say that scientists are cautious about using web processing services. And I think Guillaume's just made that point in some way. So if we ask ourselves why, I think there's an issue with transparency. So, scientists cannot necessarily see the code that's being run, so they don't necessarily understand it. There's a definite issue with robustness. So is the service always up? Will the service always give a response? And will it give a correct response? And so there's a big issue with trust. Do we trust the service provider? Have they done enough testing and validation of their service and the underlying data so that we are definitely getting back a correct result? There's probably other issues as well. And also, when we try and move into more complex operations, it gets much harder to try and validate them. So if we're doing some kind of multi-model ensemble mean or something like that, we have to do a lot of testing to make sure that we believe that the output is correct. So that's one aspect of the experience. Another aspect is the community. So how do we organize ourselves as a community? I would say if we focus on ESGF, one of the things that we've done really well is that we all install the same software for the data nodes and index nodes. But in compute, we've entertained different solutions. If we think about the impact of that, it means that there's a lot of duplication in our community. We are doing the same thing in many different ways, and even doing the same thing in Python in many different ways. So overall, there's a finite resource of developer and maintenance capability. And I think it's something that we should continue to try and strive towards, is the idea that we could converge on a single solution. And ideally, that means that we all install the same compute node in the same way that we would install the same data node or index node. So the third aspect of the experience that I think is relevant is that the code itself often becomes a problem. So when we start off, we have this nice, clean, fresh design, and it's not going to look like any other code base that we've looked at. So it starts very nice and clean and tidy, but we have a big problem that the data itself from any of these large projects, such as CMIP5 or Cordex, the data is dirty, it's heterogeneous. And that is in spite of tools and standards like CMOR that attempt to make everything much more standardized. There are lots of minor issues that can make data different and that can mean that the tools that work with data might not be able to properly interpret it and operate on it in the right way. And so eventually the code base tends to something much more complex. And actually, if we look inside a lot of our existing code, we start having code that's testing for the existence of a certain model or a certain variable, and then applying on-the-fly fixes, such as modifying a data type or metadata, such as the units for a given variable. I feel, from my experience, this is a common pattern. And a lot of it comes down to the heterogeneity of projects like CMIP5. So a proposed solution, I would say, is to build on a Python code base. Python looks like a generally popular solution for our community. We have some good tools out there, such as PyWPS, and then the Birdhouse framework that's developed by DKRZ. ENES-RI also looks like, and Dask look like other tools that are very sensible for us to build on. But equally, we should look out there for existing libraries that sit on top of those that might already do some of the things we need. This is very much reflecting what the Compute Working Team set out to do, is that we should begin with simple, basic operations. So things like subsetting, averaging, and some kind of regridding. I appreciate that we can argue whether regridding is a basic operation or not. And from my perspective, it comes back to focusing on robustness rather than focusing on functionality. So I think this is really the crux of the issue, is can we make sure that our services will work with most of the data that's thrown at them? So how do we go about doing that? So I think that we can do that by thinking about each project or activity, such as CMIP5, that we actually test all the operations or processes that we are providing against a large representative sample of the available data. So we don't test it against 2 or 3 examples interactively. We actually build a whole suite that tests a significant coverage of the different data types that we will find for a given activity. We should also validate the outputs in a comprehensive way. And so part of that is actually, in order to check the tools we're using, so if we're using ENES-RI, let's try and use other tools to do the validation, to build our confidence that the tool we've chosen is actually giving us the responses we want. And then I think another really important aspect of this is to think about characterizing the data sets that we've found in a public register. So what do I mean by that? So the idea behind characterizing is that we find the variations of character in different data sets, and that we put all these things into some kind of publicly available register. It might be GitHub, it might be some web service. And then the code that actually does the processing, that knows how to deal with the character of different data sets, it doesn't actually know the data sets, it just knows how to deal with certain types of characters, such as the units being incorrect for a certain variable, or for a time axis to be presented as a scalar variable rather than a coordinate variable or something like that. So the code itself doesn't get into knowing about particular models and variables. It knows how to deal with certain characters, and it knows how to respond to those. I think that ends up keeping the code cleaner. And the idea behind this public register is that it's something that everyone in the community could potentially use and contribute to. And so here's a little flow chart here with this idea that you you go through and you keep running your operation code on more and more data. And every time you find something that breaks, you find out what the character is of that. You characterize that input data, you adapt the code, and then you add that information to this public register of the character. So our proposal looks something like this. It's being led by us at STFC CEDA with DKRZ as major partners, and we're also working with UKRI and CRIM in Canada. And we kind of have this layered approach. So we have this idea of a client layer, and so this is sitting within the climate data store of the Copernicus system, and we're building on tools like OWS-lib and Birdie that allow you to put together some kind of request, WPS request, through an authentication layer. We then have a WPS layer, which has these, what we call data reduction WPS processes for things like subsetting, averaging, regridding. At this point, it's very much, but these are birdhouse birds, and they are deployed in a nice parallel framework. And then these actually go and talk to the operations, and the operations are all being defined in Python. We are writing them ideally in X-Array, but possibly using other tools if we need to. And we have this cycle of writing operations, testing them out on lots of data, so lots of different parts of CMIP5, Cordex, etc., characterizing them, updating our characterization, and then feeding that back into the operation code so that it can handle more of the data. So in terms of where we are now, I'm actually at ECMWF now, and I hope we've secured the funding for this. We've got 19 months to come up with a solution for this. So by the middle of next year, we should have a design and implementation available. By the end of next year, we should have the subsetting and averaging processes deployed. And then by the middle of 2021, the regridding and potentially some additional processes deployed. So in terms of your thoughts and input, I'm very keen to hear whether people disagree with this rationale and approach, because I'm sure there's a lot that we can learn from other people's experience. And I know I know that I don't have all the answers. We'd be very keen to know if others would like to collaborate on any aspect of this approach. We have some funding. We're going to have some people working in it. We're very much at the beginning of it. And I'm also very interested in this idea of this characterization register and what that might look like. So whether we could build something that as a community we can add to, we can allow different people to maintain and contribute to it. And the key thing for me is that characterization is not about the solution. It's not about how you fix it in code. It's about how you define the character that then your code can respond to. Thank you very much for listening.